also known as the 68, 95, and 99.7 rule, or the 3 sigma rule, is an important concept in stats and probability. It provides a rough estimate of the distribution data in a normal or bell-shaped curve. It states that for normal distribution, approximately 68% of the data falls within one standard deviation of the mean. About 95% of the data falls within 2 standard deviations of the mean, and approximately 99.7% of the data falls within 3 standard deviations of the mean. It's valuable for a few reasons. It helps to visualize and understand the distribution of the data by knowing the properties of data falling within different standard deviation ranges. We can get a sense of how the data is spread around the mean. The empirical rule provides a guideline for identifying outliers. Data points that fall beyond 3 standard deviations from the mean are considered rare outliers. If data points fall within 3 standard deviation range, they are considered more typical or expected. The empirical rule can be used to assess the quality of the data. If a data set violates the empirical rule significantly, it may indicate errors, anomalies, or non-normality in the data collection process. The empirical rule allows for rough estimates of probabilities in a normal distribution. For example, if a variable follows a normal distribution, we can estimate the probability of a data point falling within a certain range based on the empirical rule itself. It is important to note that the empirical rule is an approximation based on the assumption of a normal distribution. While many real-world phenomena exhibit some degree of normality, not all data sets conform precisely to this normal or bell-shaped curve. Nonetheless, the empirical rule provides a useful starting point for understanding data distributions and making informed decisions based on them. Draw a normal distribution, mu equals 0, and the standard deviation equal to 1, and find the percentages for all of the areas between all the values on the horizontal axis using the empirical rule. So I've already have the empirical rule drawn out for us. Notice this is a normal shaped curve, so our mean is right here in the center. And then we go out +1 and -1 standard deviations from the mean. So when I add together this area, we end up with 68%. Then if I go an additional plus or minus, I then have 13.5% here to here on each side. So when I add all of this area in between, we have 68%. And then if I go within a third standard deviation, we now get to add in these values. So when I add all of the percentages in between positive and negative 3%, we end up with, we had 68%. This is 95% for those who were trying to add my math and it was incorrect. And this last one is 99.7%. Use the empirical rule. For each problem, draw and label the graph and then answer the question. So I already have the graph labeled here for us. You can find this using Google Images if it's helpful just to grab a few of them or just quickly draw one by hand. It's telling us that the weights of an adorable month-old goat babies are normally distributed. So we can assume it's a normal curve with a mean of 13.2 pounds and a standard deviation of 1.3 pounds. Using the empirical rule, what percent of 1-month-old kids weigh between 10.6 and 15.8 pounds? So I'm going to start with 1 standard deviation. So I'm going to take the mean plus 1 standard deviation. And in this case, we know that the mean is 13.2, and I'm going to add 1 standard deviation. So 14.5. And then I'm also going to do minus 1 standard deviation. So 13.2 minus 1.3 is 11.9. So on our table here, 1 standard deviation on the low side is 11.9, and 1 standard deviation on the right side is 14.5. Well, we want in between, so it's got to be more or less. So if I do 2 standard deviations, I will take the mean plus 2 standard deviations, or 13.2 plus 2 times the standard deviation of 1 3/10, and we will get 15.8. So this is 15 oops, I write that a little nicer for you. And then if I did the mean minus 2 standard deviations, we'll take 13.2 minus 2 times 1.3, and we get approximately 10.6. So notice we reached 10.6 and 15.8. So in between here and here, so we want to add all of these probabilities together. And when we do so, that is, of course, the 95%, since it's within 2 standard deviations. So I can say that 95% are between 10.6 and 15.8 pounds. What percent are between 11.9 and 14.5? Well, grabbing the information that we had on the previous page, we decided that 2 standard deviations was 10.6 to 15.8. We decided 1 standard deviation was 11.9 and 14.5. So it's asking what percent are between 11.9 and 14.5. Well, that's in between 1 standard deviation, so 68% are between 11.9 and 14.5 pounds. Using the empirical rule, find the percent of 1-month-old kids who weigh more than 14.5 pounds. So thinking about, we had 10.6 at 2 standard deviations on the lower part, 11.9, 14.5, 15.8, and if I did 3 standard deviations, right, if I added another 1.3, we would be at 17.1. We want more than 14.5. So we have 14.5 and we want more than that. So we want all of this area which encompasses more than 14.5 pounds. So I want to add all of these percentages together. 13.5 plus 2.35 plus 0.15, 16% are more than 14.5 pounds. In a random sample of 75 1-month-old kids, how many would be expected, so we're thinking about expected value, to be more than 14.5 pounds? So we already said that 16% is the probability. We're looking for 75 of those, so we're using our expected value, which is the number of times we're doing the activity. So 75 of them times the probability of 16% are more than 14.5 pounds. So we would expect that 12 1-month-old baby goats out of those 75 would be more than 14.5 pounds. Let's fill in our table with what we know. We know this is 10.6, 11.9. The mean we said was 13.2, so if you wanted to fill in that portion, 14.5, 15.8, add another 1.3 to get 17.1, and we can do the same going backwards. Subtract 1.3 gives us 9.3. So we have all of the pieces. We're looking for that weigh less than 9.3 pounds, so weighing less than 3.9 pounds, and also greater than 15.8. So here's 15.8. So greater than 15.8. So we want to add all these pieces together. So we have 0.15% plus 2.35% plus another 0.15%. So about 2.65% would weigh less than 9.3 pounds and greater than 15.8 pounds. And that takes care of using the visualization of the empirical rule to help us look at some probabilities.